Darlington Pair is a multi-stage BJT amplifier. It provides good amount of input impedance, which is more than input impedance of a single stage BJT amplifier. It also provides huge amount of current gain, more than provided by a single stage BJT amplifier in any configuration. Even though it provides more input impedance, more current gain, it was designed to provide more input impedance. When input impedance of the amplifier is low, then amplifier loads the signal source. Loading of signal source leads to deterioration in the performance as well as reduction in the lifetime of the signal source. Therefore, input impedance of the amplifier requires to be high. Darlington Pair is able to provide good amount of input impedance. It is basically two CC stages coupled with a direct coupling mechanism. As it provides huge amount of gain, current gain, it is called super beta circuit. One can use two PNP transistors or two NPN transistors to design a Darlington pair, but when one NPN transistor and one PNP transistor are used in the design, the resulting pair is called complementary Darlington pair or Jicloy pair. Multi-stage amplifiers, Darlington Pairs, series on semiconductor devices and circuits, lecture number 8.11. Darlington Pairs are multi-stage amplifiers. There exists two stages in the structure of these amplifiers. That's why they are called pairs, Darlington Pairs. Each stage employs a BJT, bipolar junction transistor, in CC configuration. So there exists two CC stages in the structure of Darlington Pairs. The coupling between the stages falls in the category of DC, direct coupling. Darlington pairs are meant for providing more input impedance. Single stage BJT amplifiers, they provide input impedance which is usually low. This low input impedance leads to loading of the signal source. Loading of the signal source leads to deterioration in the performance of the source and also fall in the life period of the source. Hence, for longevity, more input impedance is required. To enhance the input impedance of BJT amplifiers, Darlington pair it has come into being. Darlington pair, in addition being able to enhance the input impedance, it is also capable of providing large amount of current gain. One interesting point to be noted here is Darlington pairs are always with the BJT amplifier stages, always 2cc stages. There exists no Darlington pair in the FET world. There is no Darlington pair with the FET stages. The reason is each FET stage is able to provide, each single stage FET amplifier is able to provide more than necessary input impedance. Hence, there is no need to go further enhancement of the input impedance as far as FET amplifiers are concerned. This explains why there is no FET version as far as Darlington pairs are concerned. With this small introduction now, we move to the course session. Let us begin with a simple question. What is Darlington pair? Question is simple, answer is also a simple one. It can be viewed as SCC amplifier modified by the addition of another CC. CC configuration offers good amount of input impedance when compared to other configurations, CE or CB. But even that input impedance is not sufficient to keep the source remain unloaded, to protect the source from the ill effects of loading by the amplifier. Loading means simply drawing current. Signal source is there to provide a signal. It is not meant for supplying current. So the current drawn by the amplifier from the source, it should be as small as possible. It remains small only when the input impedance of the amplifier is high. Even though CC stage has more input impedance, it is not sufficient. So it has to be increased. This increase is achieved by the addition of another CC. So structurally, Darlington pair is CC followed by another CC. Why Darlington pair? To have more input impedance. And of course, Darlington pair is able to provide more current gain too than provided by a single CC stage. This pair was invented by American electrical engineer Sidney Darlington while working at Bell Labs in 1953. A Darlington pair which uses transistors of opposite type, one NPN and another PNP. This pair is called complementary Darlington pair or Jikolai pair. Compared to single stage emitter follower, single stage CC amplifier, Darlington pair provides higher current gain, as already mentioned, higher input impedance. Actually, in the beginning, when it was first invented by Darlington, the purpose for which it was invented was to have higher input impedance. Of course, once the design come into being, current gain, more current gain also has come into the reality. Voltage less close to unity, lower output resistance. These are the features of Darlington pair. In the market, Darlington pair is available like a transistor. Inside the transistor, there exists two transistors, Q1, Q2. When I say it is available as a transistor, I mean 3 terminals are available to the user. One terminal is base, another terminal is emitter, third terminal is collector, with some internal wiring between the transistors Q1 and Q2. These are wired, Q1 and Q2 are wired. To the outside, we have only three terminals, base, emitter, collector. In B is shown electrical circuit. Here important point is the output of Q1 first stage is taken from its emitter and it is given to the base of Q2. The understanding becomes easy once you realize that there exists a high resistance connecting emitter terminal to the ground. This high resistance is load. It is so high that we can consider it as infinity or open circuit. It is open circuit. So open circuit is the reality and we can consider it as a high resistance. So load of Q1 is high resistance. So output is taken given to Q2. Some more points. It is a composite pair of two transistors. The input resistance of second transistor constituting the emitter load for the first. Now in this diagram, this is open circuit and this open circuit or high resistance is in parallel with the input resistance of Q2. As load resistance is high and this high resistance is parallel to input resistance of Q2, effective load resistance of Q1 becomes nearly equal to input resistance of Q2. More specifically, Darlington circuit consists of two cascaded emitter followers with infinite emitter resistance in the first stage. This point has already been mentioned. It can be operated in two configurations, CCCC, CCCE. CCCC is called Darlington emitter follower. CCCE is called Darlington CE amplifier, common emitter amplifier. CCCC is a highly useful configuration. In CCCC, collectors of two BJTs are tied together and the emitter of one is direct coupled to the base of the other. This aspect we have already seen in the diagram shown in the previous slide. This combination is used in amplifier circuits as if it were a single transistor having base, collector and emitter terminals. The Darlington pair is most often used in an emitter follower configuration for its excellent buffering between high impedance source and a low impedance load. It is used for its high input impedance. It is used for its high current gain. Another application is for buffering. It is also used for its excellent buffering characteristics. The CCCE pair or Darlington common emitter amplifier, this is another configuration of Darlington pair, has advantage of having very large overall current gain equal to product of CE short circuit current gains of transistors. The gain of the pair can be as high as 30,000. As already mentioned, Darlington pair is well known for its large current gain. For this reason, it is called super beta transistor. Beta is current gain, of course, it is DC current gain. The effective beta of Darlington pair, beta dP, is beta dP equal to beta 1 plus beta 2 plus beta 1 beta 2. It is roughly product of beta 1 beta 2. Beta 1 is let us say if it is 100, beta 2 approximately if it is 100, beta of the pair becomes 100 into 100, 10,000. 10,000 value for beta is not an ordinary thing. That's why it is called super beta transistor. Typical value for current gain of the composite pair is 430, whereas for input impedance Ri, its value is 1.73 mega ohms. Here, one point to be kept in mind is AI, current gain. This current gain refers to differential current gain or small signal current gain. Beta is also current gain, but that is large signal current gain. Now, AI of Darlington Pair is 430, input impedance is 1.73 mega ohms. For a single CC stage, current gain is 40. So current gain is almost 10 times more. Input impedance of single stage is 409K, but for the pair it is 1.73 mega ohms. So from this one can see current gain is enhanced by an huge amount. It has no FET version, as a single stage FET amplifiers give enough input impedance and hence no need to go for any modification. Here is shown the Darlington pair in operation. This is source, this is bias supply, Q1, Q2, both are PNP transistors. Here is the load. This load can be assumed to be infinity. So open circuit is the load of Q1. It is in parallel with input impedance of the Q2. So effective load impedance of Q1 is input impedance of the Q2. This is already mentioned. So this is CC stage. This is also CC stage. Notice output is being taken from emitter terminal. Here also it is being taken from emitter terminal. For the sake of simplicity, here the bias arrangements are not shown. Complete bias arrangements are not illustrated in this diagram. Now a few expressions. Current gain, small signal current gain or differential current gain of the pair is AI1, current gain of first stage multiplied by AI2, current gain of second stage. It can be shown equal to 1 plus HFE whole square by 1 plus H0E HFE RE. Here HFE, HOE, HFE, these are all hybrid parameters. RI1 means input impedance of first stage. This is also input impedance of the pair. It is equal to HIE plus AI1 RI2. It is roughly RE into 1 plus HFE whole square by 1 plus H0E HFE RE. Voltage gain is 1 minus HIE2 by RI2 multiplied by 2 plus HOE HFE RE. This is voltage gain. Output resistance of the pair is sum of two parts. First part is RS by 1 plus HFE whole square plus 2 HIE2 by 1 plus HFE. Typical values. RI input impedance is 1.73 mega ohms. Current gain is 427. These values we can obtain by substituting H parameter values from the transistor characteristics and also typical value of RE. The voltage gain is less close to unity than single stage emitter follower. The output impedance may be greater or smaller than single stage emitter follower. Bootstrapping. What is bootstrapping? So far we have not considered the effect of bias circuit on the input impedance of the pair. It is being mentioned that input impedance is high, but this high is only when bare transistors configuration is considered. When bias circuit is also taken into account, considered, then it is noticed that there is a fall in the input impedance of the pair. To overcome this shortcoming, to get back the input impedance of the pair to its original high value, one circuit technique is employed. It is called bootstrapping. The input resistance of Darlington can be greatly increased by bootstrapping it through the addition of capacitor C0 between first collector and the second emitter. The input resistance, which was 1 by H0B, approximately 2 mega ohms earlier, becomes 1 by H0B multiplied by 1 minus AV, roughly 400 mega, after bootstrapping. So bootstrapping is simply a circuit technique. It is implemented with the help of a capacitor. Certain merits are there for this circuit. They are being mentioned here. Large current gain. As the overall current gain is large, they are used for large current applications like enhancing the current supplying capacity of voltage regulators. It is also acts as an ideal current source. The high current gain, high input impedance with voltage gain very close to unity makes them nearly ideal current sources. Demerits are also there. More leakage current. The leakage current of the first transistor gets amplified by the second one, thus resulting in large overall leakage current. Lowering of input impedance. The initial large input impedance comes down when biasing arrangement is applied. However, this lowering of the input impedance can be prevented by adapting bootstrapping technique. Regarding this, we have already discussed in a previous slide. Some more demerits. Doubling of base emitter voltage. Since there are two junctions between base and emitter of Darlington pair, base emitter voltage gets doubled for silicon transistors where each VB is about 0.65 volts and the device is operating in the active or saturated region. The necessary base emitter voltage of pair becomes 1.3 volts. It is a drawback. Increased saturation voltage. This pair has increased saturation voltage, and for equal collector currents, it translates into an increase in the dissipated power when compared to that of single transistor. Some more demerits. Switching speed reduction. Switching speed, a response of the pair decreases because of the first transistor cannot actively inhibit the base current of the second one, making the device slow to switch off. Switching speed reduction means low bandwidth, slowing down. Another demerit is more phase shift. The Darlington pair has more phase shift at high frequencies than single transistor and hence can more easily become unstable with the negative feedback. Requirement of power amplifier, another demerit. In order to have reasonable operating current in the first transistor, the second one may have to be a power stage. With this, we come to an end of the session. Before closing down, let us recollect. Here, Darlington pair is introduced. Its features are given. Its properties are described. Its utility, its merits, demerits, all are given in this session. Hope this session is useful to you. We meet again in another session with a new topic.